In most cases, the service supplied to single-phase customers is rated at 120/240 volts. 120/240 volts is secondary distribution voltage that provides the customer with two voltage options: 120 volts, which is typically used to power electric lights and small appliances such as TV sets and radios, and 240 volts, which may be required to operate electric ranges and some electric dryers, air conditioning units, and other 240-volt equipment. We'll use this simplified illustration of the primary and secondary winding in a single-phase transformer to demonstrate the internal connections that we shall refer to as conventional transformer wiring. Now here's the primary winding of the unit. One end of the winding is connected to the H1 bushing on the transformer. In this example, the other end of the winding is connected to the H2 bushing on the transformer. Here are the two individual coils that make up the secondary winding of the transformer. In this example, there are three secondary bushings mounted on the unit. Inside the unit, an end of one of the secondary coils is connected to the X1 unit. An end of the other secondary coil is connected to the X3 bushing. The remaining ends of both coils are joined together at the X2 bushing. In most cases, the X2 bushing is connected to ground. In this arrangement, the coils making up the secondary winding are in series. 120 volts can be supplied by connections to the X1 and X2 bushings or by connections to the X2 and X3 bushings. In both cases, the ground on the X2 bushing splits the secondary winding into two equal coils, each capable of supplying 120 volts. The secondary winding can also supply 240 volts. This is accomplished by connections between the X1 and X3 bushings. With this in mind, we can begin to see what the secondary bus supplied by this single-phase transformer will look like. It will consist of three wires. One wire, usually referred to as the neutral, is connected to ground and the X2 bushing. The remaining wires, generally called hot legs, are connected through leads to the X1 and the X3 bushings. Connections between the grounded neutral and either one of the hot legs will supply 120 volts. Connections between the two hot legs will supply 240 volts. There are, however, a couple of things that you need to realize about this example. First, the polarity of the transformer used for our demonstration is additive. This means the secondary bushings are designated as X3, X2, and X1 when read from left to right. If this unit had subtractive polarity, the ends of the windings connected to the X1 and X3 bushings would be swapped internally. The secondary bushings would then be designated X1, X2, and X3 when read from left to right. Another thing you should realize about the example that we demonstrated is that some transformers have 4 secondary bushings instead of 3. On transformers with 4 bushing arrangements, the ends of the two coils that make up the secondary winding are each connected internally to a separate secondary bushing. This design provides the flexibility of changing the wiring of the secondary winding without having to go inside the transformer to change connections. To connect the secondary winding of this transformer in a conventional manner, the X2 and X3 bushings, which are connected to the ends of separate coils, are joined together by a metal strap or jumper. Here's what it looks like in the field. With this jumper in place, the connection between the X2 and X3 bushings functions as a single bushing. The X1 and X4 bushings become the hot legs of the unit. The combination X2 and X3 bushing serves as the ground point between the two secondary coils. Connections to the X1 and X4 bushings will provide 240 volts. Connections between either the X1 or the X4 bushing and ground will provide 120 volts. On this unit, for example, the voltage rating is 7620/13200Y. As we said earlier, the first number indicates that the primary winding is rated and insulated to 7620 volts. The second number, 13200Y, indicates that the transformer is designed to be used on a 13.2 kV Y system. When all connections are made and the unit is energized, 7620 volts will be supplied to the primary winding. The voltage induced in the secondary winding will provide 240 volts to connections between the two hot legs and 120 volts to connections between either one of the hot legs and the grounded neutral.